Hello and welcome to the third part of the video series, First Steps in Facade Construction. In the first and second videos, we created a facade in combination with Logikal. In the second part or the second video, we already set up a kind of detailed plan that we will also use further on. Here, of course, more details will be added. And in this video, I would like to start with the brackets. This means I want to create floor brackets in a certain way. Then here in the intermediate ceiling, I would like to make a connection. And I also want to go further down. I will directly pass these modifications to Logikal so that they can be seen this way. Now I would like to start right away, which means that since I know I want brackets here, I will define a new area immediately. Here is my steel construction. In this case, by steel construction, I mean that it will be for the entrance facade. That means we will also create a sub area right away. Entrance facade. Here will be all my steel parts for the brackets for the facade. I will also reference this externally right away, meaning that I am sure I will need it in the future. The first step, probably not yet. Of course, I could use this at a later time, but what I do right away. I also don't forget. That means I always like to do it at the very beginning. So, first, I would like to start here with the intermediate brackets. That means I will simply hide the parts that I do not need here. I want to isolate this and this. And the facade, that one. Now I've picked the wrong one again. That part, and of course the facade, so that I can come to you more easily with the configuration or selection. And I would like to start here with the command. This means that in the first step, I will simply take a standardized connection where I can also select predefined values. This means I will select the post here and the part where it is to be connected. And the point defines for me here where the bracket should be placed, or from this point I can proceed. So now I basically have the values that I need to go through here, which means here is the gap, h, the height. So this height in this case. Then I go to where the first screw should be placed. I also need to consider the width of the casing plates, which means here I set it to 120. And what is actually most important is this point, the 0. So where I have set my point, I also want to have the bracket there. Here I could also define another value, which is now the height of the bracket and the plates. Then what kind of fastening do I want? I can set everything here. Which plate do I want? Do I want casing plates here? Or do I want to have this in PVC for the meter? Then I can set the sheets as usual. I want a weld seam. I will just say preview so I can see what I have set here, and I see that I still need to optimize the connections a bit. This means the geometry, in this case the W, was too short, so I will set it to 150 for the bolting. I also set the values too high. I could of course also turn off the anchor bolting, but basically I need to define the offset in X in this case, which means I will change the number in X to 30 and update the preview. Of course, we just need to go through the dialogues here. That means the 30 wasn't good. So let's do it this way. What I see here, since I am working with material colors, is that I have chosen the wrong sheet for the C. This means I would like to have a sheet made of steel 10 mm thick, and actually for the B, the lining sheets should be made of PVC. Therefore, from my perspective, it is always very beneficial to work with colors here, as it allows one to quickly see what has essentially been installed. With OK, I can hear this console. Installing, you can also see here that the modifications to the post have been added, and what is important now is that I want to add this to my steel construction. This means that these connections should actually belong to my steel construction in another respect. If it fits, I can of course copy this, meaning I want to set an edge and say, in this case, OK. Next, this post should also come back to this part in the middle, and I basically go through it so that it is centered. And the same here. So that means I have now created these consoles with the connections. Of course, one must always pay attention. In this case, I haven't changed much. What is important now is that I display my construction kit so that I can see if I can manage with my air gap. That means I have enough space here, of course here as well, and in this case, this type of console, it is defined. So now I have this steel construction for the entrance facade. I have created the parts, and I want to go into detail because in my detail I do not yet have this steel construction included. So these consoles of the steel construction, because there could certainly be more coming, there will definitely be various sheets coming. But in this case, I make sure that the world coordinate system is set. With the right mouse button, I can go back here and say, okay, I want to insert my steel construction from the entrance facade. Here, you can again define the position correctly by right-clicking twice, and you can already see it in detail. I update this, and I have this console correctly placed here. Of course, I can work with different display styles, meaning I can say, okay, I want to use this representation or not, but we will get to that later as it continues. This means you can see that this console has also been immediately added in all areas. Of course, there are other ways I can incorporate these things here. For this, I also parameterized and documented a console myself. That means I will simply hide the side parts here so that it is literally easier to see. It flows naturally, and now I have the opportunity to solve this in other ways. This means I can go here. I have also organized it so that I need to lay down the processing level. When I go into the catalog, I can access construction options, and here I have posts and consoles where I can select various options that I have parameterized. For example, for the original insert for the 150. So this console is set up in such a way that if I right click twice here, it is basically positioned correctly in the construction. What I need to pay attention to now is that this console needs to be placed back in the right position. And I will move this console to the correct spot, meaning I will set this console on the floor. With the Enter key, I can access the point options and can say that these should be pulled down here. So now I can set various values here. That means when I activate my variables here, for example, this console has simply defined a variety of values. That means when I click on this particular option, I now have various options, such as to influence this dummy body and make adjustments. For example, this dummy body is, among other things, for the length of. For the recess, for the width, I can define everything. This means I can define the insertion length here. For example, I want to set it to 350. I can define the width of the base plate here, and I can change this at any time. I said that I would simply set it to 180 so that it looks a bit better. You can see that everything stretches out here, and the most diverse values are defined, such as the position and length of the base plate. How long should it be? I will just change it so that it looks better again. This means I have the dowels out. I could also influence the position of the dowels, or for example, how long or how large this recess should be. This fits quite well. And in this case, I have defined my console. And I would like to copy this console afterwards. That means I take this one, copy it, and just say this point is my reference point, copy it to this location, and I have to see if it fits, and it does fit. So just add it at this point. At this point, I could change the width using these variables at any given moment in time, even if it doesn't seem necessary right now. So in this case, I have defined and comprehensively and thoroughly integrated these consoles, and now I want to clarify in a detailed and comprehensive manner what I have done. This so-called body, the cuboid you see here, was included in the parameterization primarily and simply to define the position, as you can clearly and evidently see. I can just say I go to the post, and in this particular scenario I want to train here and want to subtract this cuboid. Now I simply get the question of whether the second part should be retained. In this case, I can say yes or no. I want to consciously subtract this body in a deliberate and intentional way, so that it is really removed, and ensure it is completely and utterly removed. For the second part, I say no. And now this body is completely and thoroughly deleted. I go to the next post and can easily and effortlessly repeat the last command. This button is off and effortlessly and simply repositions the cuboid. For the second part, I say no, and it is completely deleted. This is how I essentially go through these parts. Here, a message simply appears that certain conditions are no longer consistent, because a lot has been done on these cuboids indeed. So in this case, I just want to take a closer and more detailed look at this processing. This means that you can see how this post would look in this case due to this cutout. So, when you have similar brackets repeatedly, it definitely makes sense to parameterize them. This means we have essentially processed the post in such a way that we have this insert here. Of course, we still need a screw connection, which I could also create. Here you can already see it, meaning the holes are essentially here. If I create a screw connection here, I want to generate a screw connection with exact detailing. I want to screw it together completely. So I select my plane and can define my screw connection here. This means I want to use a washer, so I can assemble my screw connection here. I would also like to have a screw here, and can say that I might want a slot here, for example. This means you could switch to a slot, but I don't want that at the fixed point, and say that the post should be connected with the insert, meaning it should be screwed together. They will be resolved afterwards because I am working with referencing. This means I want to define this screw connection in X, I want 2 screw connections in Y, and can create it, for example, with the grid. Now I press the key on the keyboard, the R key, and say, okay, from this center point in X, I want 0, and in Y I want to go up by 50, and thus I have my screw connection directly integrated. However, I still want to use this screw connection in steel construction later on. But you can see I have my holes for the brackets here, and this is simply the connection I selected via Logikal. Now the next step is that I could continue to copy the screw connection. For that, I will automatically assign these parts again, and then I would also have the holes on the other posts. But now the next step is that I want to hand over these modifications, or rather this modification I have so far, back to Logikal. I just want to see everything again, so I display everything. This means I go into metal construction and can say, for example, that I want to transfer my modifications to Logikal. For this, I simply need to select the position here, and it will be analyzed for me. First, the interface is loaded, and then my edits are transferred. So, I have now received the message that the edits have been transferred to Logikal, and we will now take a look at them in Logikal. That means I'm going to BRZ processing and would like to take a look at the post here. So, for me, in my opinion, at the left post, we did the best work, which is why we are confidently taking this post. As you can clearly see here, that I have these holes for the screw connections and also the necessary slots. I attempted to rotate this, however, it's not quite working as expected. Okay, so you can clearly see that these processes are indeed present, which can be seen a bit better now. This essentially means the slots, these specific slots, the standard processes, and of course the necessary holes for the brackets in the ceiling. You can also see afterwards that these processes come from an external program, which in this particular case is the HiCAD, the leading system. You can also see in the preview which type of processing it is. This means that the position of the hole can only be defined by the HiCAD in this case. It is also important to know that for the processing tasks, these tasks must be created that are recognized by Logikal. In other words, basically, since the HiCAD can produce any kind of machining, one must pay close attention to working a lot with holes, slots, and rectangular pockets. It is also important to know that, for example, when specifically making a rectangular machining, as seen nicely here, one must consider how this part will be machined. When a cutter comes in, it naturally has a rounding. This means that one cannot actually process a real rectangle because Logikal cannot rework it, as there is no proper tool available that can cut a rectangle out of a profile. This applies to the normal machining centers. So, we have now clearly seen that the processes are there, and in this case, we have taken the next steps.